All right, so we're going to look at how to calculate the freezing and boiling point of a solution based on colligative properties. This is the same problem that's in your notes, but I wanted to make sure that we were understanding how to do this calculation. So we have two equations, one for freezing point and one for boiling point. Change in boiling point is equal to the boiling point constant times molality times your I value. I value is the number of particles that are dissociated in solution. If the substance is a non-electrolyte or molecular, that means your I value is 1. If it is an ion or ionic compound, it's how many ions are produced in solution. So we practiced this idea with electrolytes and non-electrolytes last week. Change in freezing is the same equation, except you're going to use the freezing point constant instead of the boiling point constant. For water, your boiling point constant is 0.512 degrees Celsius per molal. For your KF value, your freezing point constant, it's 1.86 degrees Celsius per molal. Both of those constants will be given to you on a test. You don't have to memorize those, you just have to know how to use those. All right, so in order to do this problem, the first thing we have to do is figure out the molality of the solution. We have 124 grams of barium nitrate, and we're going to turn that into moles using molar mass. Molar mass of barium nitrate is 261.3 grams for every 1 mole, which leaves us with 0.475 moles of barium nitrate. We're going to divide that by kilograms of solution. We had 550 grams of water, which is 0.55 kilograms. That leaves us with 0.86 molal. Now our I value for barium nitrate is 3. Barium nitrate, when it dissociates, produces 1 barium ion and 2 nitrate ions. So our I value here is 3. So to figure out our change in boiling value, it's going to be our boiling point constant, 0.512 degrees Celsius per molal, times our molality of 0.86, times our I value of 3. That comes out to be 1.3 degrees Celsius. Since our boiling point of water is originally 100, and this is boiling point elevation, that means our boiling point is increasing by 1.3 degrees Celsius for a total of 101.3 degrees Celsius. Now for freezing, we're going to use the same equation, but our freezing point constant, 1.86 degrees Celsius per molal times 0.86 molality times our I value of 3. Our change in freezing comes out to be 4.8 degrees Celsius. Since our freezing point of water is originally 0, it's going to be 0 minus 4.8, which comes out to be negative 4.8 degrees Celsius. All right, so we're going to do a problem now where you have to find the molar mass of an unknown substance based on the colligative property of either freezing point, depression, or boiling point elevation. This one is a freezing point problem. This is also the problem that you have in your notes. So in the lab, the freezing point of a solution of a non-electrolyte was determined to be negative 2.26 degrees Celsius. 76.6 grams of the unknown non-electrolyte was dissolved in 0.350 kilograms of water. What is the molar mass of the unknown substance? So in this problem, they're telling us a few things. They are telling us that we have a non-electrolyte. So right away, we know our I value is equal to 1. Non-electrolytes do not dissociate in solution, so they just produce one particle. We also know that the boiling point value is negative, or the freezing point value rather, is negative 2.26 degrees Celsius. Because this is the freezing point, we want the change in freezing point. Change in freezing point would only be 2.2 degrees Celsius because that value is subtracted from 0. They also tell us that we have 0.350 kilograms of solution. We're going to need that a little bit later. And then we're trying to find molar mass. It is so important that you remember molar mass is how many grams you have per moles of substance. In this problem, we know how many grams we have. We have 76.6 grams of our unknown substance. What we need to find then is our moles. To find that, we're going to use our equation. Change in freezing is freezing point constant times molality times our I value. And remember that molality is moles per kilogram. So we know change in freezing, we know our freezing point constant, we know our I value, and we know kilograms. So ultimately, we're going to be able to solve for moles here. So we're going to plug everything into the problem here. 2.26 degrees Celsius equals 1.86 degrees Celsius per molal times molality, we're going to solve for that, times 1. So solving for molality, we'll put an X by it since that's what we're trying to find. We would divide both sides by 1.86. And when we do that, our X molality value comes out to be 1.22 molal. Now remember, molality is how many moles you have per kilogram. So if I have 1.22 moles for every 1 kilogram, how many moles do I have for 0.350 kilograms, which is how many kilograms of solvent of water that we had? So we would go and cross multiply here. And when we do that, we get 0.427 moles. That's how many moles of our solute we have. So we're going to go back to our original molar mass equation, which was 76.6 grams divided by our unknown amount of moles, 0.427 moles, and that leaves us with 179 grams per mole for our molar mass.